children. Today, Bindu and Persis is here with you. To give you some interesting information on heat. We understood that hot and cold are relative terms and heat is a form of energy. We use the terms temperature and heat to describe the state of an object. These words technically have special meanings. Let's find out the difference in this session. Learning outcomes. At the end of this lesson, students will be able to understand the concept of heat and temperature, the absolute scale of temperature, the thermal energy and the thermal equilibrium. Keywords: temperature, heat, thermal equilibrium. Concept map. To understand their meanings, let us do an activity. Look, we have taken a piece of wood and a piece of metal and kept them in a fridge or ice box. After 15 minutes, we took them out and touched them. When we keep materials in a fridge, they become cold. That is, they lose heat energy. The iron and wooden pieces were kept in the fridge for the same period. But we feel that the metal piece is colder than the wooden piece. So, if you feel that the metal piece is colder than the wooden piece, it must mean that more heat energy flows out of your body when you touch the metal piece when compared to the wooden piece. In other words, the degree of coldness of the metal piece is greater than that of the wooden piece. The conventional definition of temperature is the degree of hotness or coldness. When two bodies are placed in thermal contact, heat energy will be transferred from the hotter body to the colder body. This transfer of heat energy continues till both bodies attain the same degree of hotness or coldness. At this stage, we say that the bodies have achieved thermal equilibrium. What is temperature? How can you differentiate it from heat? We know that bodies in contact achieve thermal equilibrium. Due to the transfer of heat energy. When you keep the thermometer in the hotter body, you observe that there is a rise in mercury level. This happens because the heat gets transferred from the hotter body to the colder body. Mercury in thermometer. Similarly, you will observe that for a colder body, the mercury level comes down from its initial level. Because of the transfer of heat from mercury, hotter body, to a colder body. Thus, we define heat as follows. Heat is a form of energy in transit that flows from a body at higher temperature to a body at lower temperature. Heat does not stay where we put it. Hot things get colder and cold things get hotter. Heat transfer takes place when heat energy flows from an object with a higher temperature to an object with a lower temperature. The SI unit of heat is a joule. J, and the CGS unit is the calorie, cal. The amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius is called calorie. The SI unit of temperature is Kelvin, K. It can also be expressed as degrees Celsius. 0 degrees Celsius is equal to 273 Kelvin. Absolute zero. The temperature at which the pressure and volume of a gas theoretically reaches zero is called absolute zero. Unit of temperature. The SI unit of temperature is Kelvin, K. For day-to-day applications, Celsius, degree C is used. Temperature is measured with a thermometer. There are 3 scales of temperature. Fahrenheit scale, Celsius, or centigrade scale. Kelvin or absolute scale. Temperature and kinetic energy. We shall take 2 bowls, one with hot water and the second with cold water. Gently grains of food color are sprinkled on the surface of the water in both bowls and observe the motion of the small grains of food color. You will notice that the grains of food color jiggling move randomly. This happens because the molecules of water in both bowls are in random motion. We observe that the jiggling of the grains of food color in hot water is more. When compared to the jiggling of cold water. We know that bodies possesses kinetic energy when they are in motion. As the speed of motion of particles, grain of food color in the bowls of water is different. We can say that they have different kinetic energies. Thus, we conclude that the average kinetic energy of molecules or particles of a hotter body is greater than that of a colder body. So, we can say that the temperature of a body is an indicator of the average kinetic energy of molecules of that body. The average kinetic energy of the molecules is directly proportional to the absolute temperature. Points to remember. Heat is a form of energy in transit that flows from a body at a higher temperature to a body at a lower temperature. SI unit of heat is joule. Its CGS unit is calorie. 1 calorie is equal to 4.186 joule. When two or more bodies at different temperatures are brought into thermal contact, then the net heat lost by the hot bodies is equal to the net heat gained by the cold bodies until they attain thermal equilibrium. The average kinetic energy of the molecules is directly proportional to the absolute temperature